Hello, and thanks for joining me for getting started with Qt for MCUs. Today we're going to build our first application, load it on a device, and explore some of the many features and benefits that Qt brings to microcontroller development. As you can see, I'm running one of our example projects, a thermostat built using Qt for MCUs. It really showcases the power of the Qt framework when applied to the microcontroller space. First, we'll get started by creating a brand new project. We'll select Qt for MCU application. I'll name it something like MCU demo. I'm going to select the kit that I want to use for my target device. Today I'm building for an NXP i.MX RT1050, and I'll also use our desktop simulator. We'll complete the construction and we're dropped right into our default entry point for QML. The project is configured and our source tree is populated. You'll notice that we use CMake for building Qt for MCU's products. The minimum required version is 3.13. And we've provided the package QUL, which stands for Quick Ultralight. This package enables building dynamic user interfaces using our Qt Quick runtime in the QML language for minimal footprint devices. We have our entry point main CPP and our entry point QML file. Let's take a look at our QML file. If you've never seen the QML language before, it's a declarative programming language using a JSON-like syntax. It's higher level than C++, but it's very easy to write and build out your user interface. It enables rapid prototyping while still maintaining the performance and flexibility of the C++ language. Within QML, we have objects, such as this rectangle, which have properties, such as width and height. And we've provided a large number of controls to simplify user interface development right out of the box. Let's get started by making some changes to this QML file, and then we'll see it run on the device. First, I know I need to increase the size of the font to make it a little more readable, and I'd also like to give a nice background color to this rectangle. I'm going to use CSS style color values. We can also use the common color names as seen here. And with those changes in place, I will click the build and run, which will build and compile and flash onto the device. And we'll take a look at the device while that happens. Here you can see we're running a QML to CPP program. This compiles the QML source code into a C++ file. This is what enables us to attain the native speeds that you would like to see while still using such a high-level language. And there we have our application running on our MCU device. Let's change a few more things to make this user interface really interesting. We're going to start by adding a custom font. I'm going to copy this fonts directory over into my MCU demo. And then I'm going to open my CMake lists file and add some code here that will enable us to load a custom font. I'll save that. and we'll see it reconfigure. And then I'll build and load that on the device as well. Setting the default font family is all we need to do. All text elements within the QML UI code will make use of the default font family. You can also specify an additional font.family property if you have multiple fonts. Here we are flashing. And there it is with our Montserrat font. Let's go ahead and turn off the device camera, and we'll take a look at running this in our desktop simulator. This will enable us to make more rapid prototyping changes, build out our user interface, and load the final product onto the device and save all of that flashing time. Let's go ahead and bring in some images. I've got two images I'm going to bring, a cute logo and a background for the project. We'll copy that in. And then we're going to add those images in as resources to our project using this QUL add resource function. QUL add resource creates a RCC style format for our images. This is very similar to how you would develop your user interface in dynamic QML. I'm going to add an image object as a child of the rectangle. And I'll set the source property of that image to use the QRC : notation, images /qt_logo.png. And we'll build and run that on our desktop kit. And there's our cute image. This is great, but it's not exactly where I'd want it to be. I'd like to lay this out a little nicer. So let's put these in a column. We'll just lay these out inside a vertical column. I'm going to center the column inside the parent rectangle, but I want the text in the image to be centered horizontally within the column. So I will anchor the horizontal center line of the text and the horizontal center line of the image to their parent horizontal center. This way they won't be drawn left justified. And let's take a look at that. Much better. Okay. Now, a user interface isn't much good without the ability for the user to interact with it. So let's take a look at some of the controls that we have available within Qt for MCUs. First, I'm going to import qtquick.controls. And I want to note that the version number of the QML import doesn't matter in Qt for MCUs. That's because static QML doesn't load different versions of the plugins as dynamic QML does. Moving forward in the QML3 specification, Versions will be completely optional for all QML dialects. In addition to importing the module, I also need to link against some additional libraries to support Qt controls. I'm going to copy the additional library I need out of a Scratchpad. And you'll notice it's called Quick Ultralight Controls Style Default. This provides the default fallback style for all of the Qt controls in Qt for MCUs. But you are also able to define custom styles that can be used across your application. Now that we've finished including the Qt Quick Controls module, let's add one of the controls to our column. I'm going to add a switch button. Switch buttons have a property called checked. And you can toggle the switch on to check it and off to turn off the check property. Now, to reference properties in other objects within QML, you have to use an ID property. The ID works like a pointer to the object so that you can dereference its public properties and functions. I'm going to add IDs to a couple of these objects so that we can reference them. I like to prefix my IDs with a lowercase I. This helps me differentiate the ID reference from standard property notation. So let's begin by hiding this image whenever the switch button is toggled off. To do that, I'll make use of the opacity property. The opacity is a real value that sets the percentage of opacity for any object in Qt Quick. So when the switch is checked, I want the opacity to be 1, fully opaque. And when it's not, I'll set it to 0, fully transparent. And as you can see, I'm using a JavaScript ternary notation here. So this is creating what we call a binding. Similar to the anchors above, where we've bound to another object, this is binding to the checked property of the switch. And when that property changes, this expression will be reevaluated and updated so that the value of the opacity will match. Let's take a look at how this works when we run it on the desktop. So now we have no logo, and when I turn the switch on, the logo appears. I notice a couple of things here. First of all, my switch is not centered horizontally. I forgot to do that. Also, this opacity is a pretty instantaneous change. So let's try and make it a little more dynamic. First thing I'm going to do is adjust my centering. And you'll notice the parent is a reference to the object that immediately contains this object. In this case, it would be the column. Now within the image, I'd like to animate this opacity change. And I'm going to do that by adding a behavior object. A behavior is an object that will operate when a given property value changes. So I'm going to apply this behavior to the opacity property of our image. And the operation I want to take place is a number animation. As you can see, I just declare additional objects within other objects to composite a control that does what I want. I'll set the duration on the number animation to be 3000 milliseconds. And let's run and see how that looks. My switch is centered, and I have a nice slow animation on the Qt logo. Excellent. All right, I'm gonna do one more change. We're gonna create a more dynamic background image for this application. So first I'm going to change the color on our text to be something that'll be more visible, a black, and I'm going to set the font and make it bold. Next, I'm going to add a new image alongside the column. And actually, it'll be behind the column. I'll set the source to be qrc:// images background looping small.png, which, as you'll remember, is one of the resources that we added to our application. Now this image will be positioned automatically at the XY00 coordinate within the rectangle. I'm also going to apply an animation to this object. To do that, I will need a reference to the root and I'm going to need to apply number animation on the X property. Now this is different than a behavior. A behavior will run anytime the value of a property is changed. Number animation has to be run explicitly, and we can set specific values that we want it to use. So I want this number animation to run from 0, which is the origin point of the image, to the width of the image minus the root object's width. I want that to take place over 5,000 milliseconds, let's say. And I also want it to loop infinitely. So the root animation class has some enumeration values for loops, such as animation infinite. I only want this to be running when the switch is checked. And let's take a look and see what we get. And now when I turn the switch on, nothing happens. We can see our new image, but no animation's taking place. Why is that? Well, let's see. Because I'm referencing width without specifying an ID, it will resolve to the width property of the object that contains the reference. In this case, the number animation. To fix this, I need to add an ID to my background image. And I need to specify the object width that I care about. And now when we run it, we see the animation. That's not really what I was looking for. It's moving in the wrong direction. I probably swapped my math. Let's fix that. Swap the root and background width and take another look. That looks better. So we have a working UI now. Nice slow fade on the logo. We have a beautiful background that's animating. Let's take a look at this on the device. I'll just switch my kit to use the device kit. We'll turn on our device camera, and I'll build and flash this code. Compiling will take a little bit longer now that we have some relatively large image files in place. And now we're flashing, which will also take a little longer as it needs to upload those images. And there we have it. We have our UI with the background image, a switch button. I'm going to toggle the switch with a nice slow animation on the logo and a very smooth high frame rate background animation on the device. And with that, we've finished development of our first Qt for MCUs application on the NXP i.MX RT1050. In our next video, we'll take a look at extending this MCU application with connections back into C++.